Quadratic equation. Let's say that you are given this quadratic equation, and the question asks us to determine whether if this quadratic equation is factorable or not. So one way to determine it is by using the quadratic formula. So once again, the question asks whether if this quadratic equation is factorable or not. So in this episode, I'll be using the quadratic formula to determine if this quadratic equation is factorable or not. The quadratic formula goes like this: negative b plus or minus radical b squared minus 4ac divided by 2a. This quadratic formula is used to determine the x variable for this quadratic equation. And it also used to determine whether if this quadratic equation is factorable or not. There's other methods to use to determine if this quadratic equation is factorable or not, but today I'll be using the quadratic formula to determine it. So once again, this is the quadratic equation that we're working with. So to use the quadratic formula, we have to know the value for the b, the a, and the c. So for this particular quadratic equation, the a value will be 1, the b value will be 12, the c value will be 36. Once you have all the value, all you need to do is just plug it back into the quadratic formula to determine if this quadratic equation is factorable or not. So I plug the 12 into the quadratic formula, and as for the b squared, it will be 12 raised to the second power. As for the a, it will be 1, and the c will be 36, and the a right here will be 1. Once you plug it in, all you need to do is just do the basic algebra for it. So it will look like this. Whenever you do a quadratic formula, make sure right here you write down the minus first before you compute this calculation right here, because it will make your algebra more easy. So don't do this algebra right here. Write down the minus first and then do the calculation. So 4 times 1 times 36, it will be 144. But you have to put the minus first. So 144 minus 144 will be 0. So you're left with negative 12 divided by 2. So the answer for this problem will be negative 6. So that means this quadratic equation of x squared plus 12x plus 36 equals to 0, the x value will be negative 6. Negative 6, when you plug it back into this original given equation, it will become 0 on the left and equals to 0. The value of the x variable, which is negative 6, when you plug it into this original given quadratic equation, it will equals to 0. So every time you use the quadratic formula to solve for this quadratic equation and the answer comes out to be a whole number, so it's an indication that this quadratic equation is factorable. Let's say that if I change the original quadratic equation into negative 36, so the original quadratic equation is x squared plus 12x plus 36, right? And this time I would like to change it into negative 36. And the question asked to determine if this quadratic equation is factorable or not. So I'll be using the quadratic formula to determine that. So once again, the quadratic formula goes like this. And this is the original quadratic equation. And as for the a variable, it will be 1, the b will be 12, and the c will be negative 36. Before we were using this quadratic formula, so the c will be 36. But for this particular case, I changed the c variable into negative 36. And the question asks if this quadratic equation is factorable or not. So just plug it back into the original quadratic formula. And whenever you do the quadratic formula, make sure you put the minus first before you do the algebra right here. It'll make your algebra more easy to manage. So put down the negative and put down the minus right here first, and 4 times 1 times negative 36 will be negative 144. So whenever you have a negative with a negative, it will be positive. So 144 plus 144, it will become square root of 288. Whenever you take a square root of 288, you will have a decimal answer. So whenever you have a decimal answer, it's an indication that this quadratic equation is not factorable. So this is the two answer for this particular quadratic equation, and it's not factorable because if you take a square root of 288, it comes out with a lot of decimal number. So it's an indication that this quadratic equation is not factorable. So now that you can see the difference, if I just change the quadratic equation by just one sign, it will make the whole problem not factorable as compared to this one, which is factorable. So this is how you determine if the quadratic formula is factorable or not by using the quadratic formula.